Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning. Okay, class. Today we will proceed on topic 7 about eigenvalue and eigenvector. Okay, now we are in class numerical methods BDA 34104. Okay, about the topic 7, actually for eigenvalue and eigenvector, the learning outcome at the end of this topic, the student will be able to form a characteristic equation of a vibrating system. And the second one is the student will be able to find the frequency of a vibrating system, and the third one is the apply. The student will be able to apply the numerical methods to find the largest or smallest eigenvalue and the corresponding eigenvector. But now for today, I would like to explain more about the characteristic equation of a vibrating system. Okay, the content, okay, 7.1 is about the understanding the eigenvalue and eigenvector. As you can see here, okay, as you can see here, the vibrating, okay, on its natural frequency is like this, and then plus, okay, the external excitation where the result will be higher, okay, the resonant result. So if the vibration and the external excitation in the same, okay, in the same amplitude here, same value, it will cause you double, okay, 2 times. So this is the resonance phenomenon. Okay, so let's consider a scenario where a bridge, okay, was shaken by a wind, whereby this external shaking frequency consists of very close, okay, very close to the natural frequency. So this one is slightly same from this one. Since the external frequency met the natural frequency, the displacement amplitude, okay, this one, were then amplified. We call it resonance. Okay, the bridge was then collapsed because of the resonance, because it will be double. But if the external excitation is far away from the natural frequency, okay, then it will not cause resonant results. Okay. Therefore, we have to know the natural frequency of a system, okay, so that the dangerous external excitation that will damage the structure due to the resonant phenomenon can be identified. Okay, every system has its own natural frequencies, where the natural frequency show the characteristics, we call it eigen of the system. The natural frequency are obtained from the eigenvalue, while the mode shape are obtained from the eigenvector. Okay. So in this class, okay, for today's topics, we will discuss more on eigenvalue and eigenvector, whereby to follow the natural frequency. For the 7.2 about the solving eigenvalue and eigenvector using characteristic equation. Okay, let's say we have some vibrating system. Okay, figure point 2 show you a vibrating system with 2 meshes and 2 springs. Okay, this one is number 2, walk number 1, and this one 2. This one K1 and K2. Okay, consider a vibrating system with 2 meshes and 2 springs as illustrated in figure 7.2. The meshes are constrained to move only in a vertical direction. Okay, in a vertical direction. Okay, figure 7.2, a vibrating system with 2 meshes and 2 springs. Okay, let's say from the Hooke's law, we got F equal to Kx. K is the okay, x is the displacement and k is the okay, the springs. Okay, k is the constant. Okay, k is the constant of the springs. Okay, different k is refer to different type of spring. Okay, about the and we have a 2 here. Okay, f1 is equal to minus k1 multiplied by x1 plus k2. Okay, this one k2 multiplied by x2 minus x1. Okay, and whereby in f2 here, okay, is equal to minus k2, this one, and multiplied by x2, okay, the displacement of x2 minus x1. And from Newton second law, F equal to ma, whereby the F1 equal to m. Okay, this is the displacement, but double the prime, means that the a lah. Okay, m a equal to m x double prime. Okay, the integration of differentiation of the different displacement, okay, 2 times. And we got f2 equal to m2 multiplied by x2 double prime. So by combine both of the equation of the motion is expressed as this one, okay, whereby the ma, this one, ma plus, okay, k1 plus k2 multiplied by x1 minus k2. So this one is by combining, and then we simplify, we get it. Okay, this one is for m2 x2 double prime plus k2, okay, multiplied by x2 minus x1 equal to 0. So this one from this one. Okay, so we change all the f1 equal to m1 x1 and f2 equal to m2 x2. Okay, and then in vibration amplitude, the velocity, in vibration amplitude, velocity and acceleration are expressed as this one. Okay, where the x1 equal to, okay, v sine omega t and x2 equal to v2 sine omega t. This is the amplitude, and for the velocity, we change a bit. We differentiate, okay, this equation to be omega v, okay, sine. When we differentiate, we got cos, okay, omega t, and when the acceleration, okay, double prime, double the differentiation, we got minus omega power of 2 times v1 sine omega t. Okay, same goes to the x2. Okay, and then by substituting back in this one, okay, all the x2 ni, okay, all the x2, okay, we substitute all the x2 to be this one, okay, minus omega power of 2 multiplied by v1 multiplied by sine omega t, and then we got this one, this equation. Okay, and then we simplify this equation, okay, to be this, and we got this equation, okay, where all the, okay, k1 k2 m k omega, okay, we let all the, okay, we let all the omega into this matrix, okay. Okay, so we got this matrix, and this is the second equation, okay, whereby the k1 plus k2 over the m1, this the matrix, and then let the lambda equal to, so it just change, okay, the lambda into the omega power of 2 into the characteristic equation. Okay, then since a equal to, okay, the lambda is the characteristic, lambda is the eigenvalue, and the v here is the eigenvector. Okay, So the characteristic equation is modulus matrix A minus lambda. Lambda is the eigenvalue. Multiple by I. Matrix I. Then modulus is equal to 0. Class. Class, we continue on example 7.1. From the question asking you about to consider the vibrating system as in figure 7.2. Where the K1 is 20, K2 is 10, M1 is 1 and M2 is 1. So by using characteristic equation, this is the figure 7.2. So from the question, they are asking you to A is find the eigenvalues, find the natural frequency, and C find the eigenvectors of the system, and D draw the mode shape, and last one E is to validate your answer using free map. We go one by one. For the solution A, asking you about to find eigenvalue of the system. The given data in this question is K1 is 20, K2 is 10, M1 and M2 is 1, and from this equation ataupun from this question, please let the eigenvalue is to be omega power of 2. From the equation double dot here, I already put here. This is from the previous pages here. Where we got a K1 plus K2 equal to M1. And then this is the equation, the previous equation actually. And then we just substitute all the value inside. Let's say K1 is equal to 20 and K2 is equal to 10. Divided by M1 is equal to 1. So is you get from here here. So 20 plus 1 divided by 1, and then you have to complete all this thing lah. Minus K2 is 10, M1 is 1. K2 is 10 divided by 1, K2 10 divided by 1, blah blah blah, like this one lah. You have to fill up all this value into the data ataupun the value and then you simplify all the equation, all the data into this. And then you will get 30 minus lambda. Lambda is eigenvalue. From here lah. Lambda multiple by 1 equal to lambda. But this one equal 0 and then lambda. So 30 minus lambda and 10 minus lambda. This one, this element and this element will be minus lambda. The rest is minus 0 actually. Minus 0. And this one the eigenvector 1 and eigenvector 2. Then from the characteristic equation we got this. We just focus on this first. 30 minus eigenvalue minus 10 and so on, and then we simplify by using multiplication and minus. This one. So 30 minus this element multiply by this element, the bottom right, and then minus, minus the multiplication of this element minus 10 multiply by this element minus 10. Minus 10 multiply by minus 10 equal to 0. Then you get this, then you got this equation, and then you solve it. The final equation is eigenvalue or lambda power of 2 minus 40 multiplied by lambda plus 200. Okay, from this one 300 minus, okay, 300 minus 100 is equal to 200. And then from this you can use calculator. You press the mode, and then you press the equation. You select the equation, and then you select the quadratic to 2 degree. I will show you in the class during the tutorial later on. Okay, and then you will simplify to get the answer of lambda 1 ataupun eigenvalue 1 is equal to 5.8579, and another value of eigenvalue, the second eigenvalue is 34.1421. Okay, so you you already solved the Q 7.1a. Okay, and another question is about asking you to find the natural frequency of the system. So from the equation, okay, in the top, at the top, where we have to change, okay, the eigenvalue to be omega power of 2, meaning that we change to be the angular natural frequency. Okay, this is the equation, okay, where in order to get the natural frequency of omega ni, okay, and then we just, okay, power root of the answer lah, of the lambda 1 and lambda 2, so eigenvalue 1 and eigenvalue 2, then we can simply get the answer 2.4203 radian per second. Okay, same goes to natural frequency. When you got the angular natural frequency, and then you can convert based on this equation, this formula. Okay, F1, the frequency 1 is equal to natural frequency 1 divided by 2 pi. Then you can get the natural frequency. Okay, and the C, they are asking you to identify the eigenvector. So again, from the metric form, okay, the last before we okay, from the characteristic equation, okay, the metric form, and then we already know the eigenvalue, so we just change, okay, we just replace or substitute, okay, the eigenvalue to be like this one, okay, 30 divided minus, okay, lambda is 4.1. Okay, in this case we will calculate by using both, okay, eigenvalue. First, we are using this, okay, 5.8579, where we get it from here, and then second calculation we use this value. Okay, at the moment when we choose lambda 1 equals to 5.8579, then you can get the answer is 2.24, okay, 0.1421 v vector 1 equal to 10v, where we can okay, we get it 10v is from here, okay, okay, all this element we multiply by v1 in at the first row, okay, and then by normalizing v1 equal to 1, then we got v2, okay, this one, okay, v2 is equal to 2.4142. Okay, So eigenvector 1 is equal to, okay, 1, okay, because we do some normalizing, okay, this one v1 and is v2. V2 is 2.4142, and then from this thing, okay, since we got the second lambda is uh, 34, 34.1421. Okay. So again we change, okay, all the lambda equal to 34.1421, and then we solve the equation, we solve the characteristic equation, and then we got the value is like here lah. Then from this okay, we get this one, okay. We just use this first row, minus 4.12421 v1, okay, divided by 10v lah, okay. Okay, minus 10v, okay. Okay, sebab dah pindahkan. So when we normalizing v1 equal to 1, then we got v2 is equal to minus 0.4142. So this is the eigenvalue, eigenvector 2, where the answer is from v1 is equal to 1 and v2 is equal to 0.4142. And the fourth, okay, okay, at D, okay, the question is asking you about the mode shape. So this is the vibrating system that has been asked in this question, where we got two mesh and two spring system. Okay, from the eigenvector 1, this one, okay, and okay, from the eigenvector 1, okay, we start from here, okay, and then this is the normalized for 1, okay, the value is 1, and this, okay, is 2.421, okay. We just using scale, sketch and scale, 2.4142, where the length of this element is same, okay, same, equal to 1. So we will get the mode shape like this, okay, as compared to eigenvector 2, okay, same length, but the value is minus, so the direction is to the left, okay. First we got 1, and then minus 0.4142. So this one is minus 0.4142. So we get this mode shape. So the answer is remain like this. And for the free mat, you should open your laptop, and then you copy this, okay, copy this to get this metric form, and then you write down, or you just copy eigenvector and eigenvalue like this formula, called the algorithm ataupun algorithm, okay, algorithm or program, code, code, and then we got the eigenvector and eigenvalue like this. So I think enough for this class until example 7.1 first, and any question you may ask, you can ask in the class, in the tutorial class after this session. Okay, before we proceed for others, okay, please also study about the 7.2 and so on. Okay, thank you class.